Good morning, students. Hope you all done your chemistry works, and I'm looking at your work. It was really good, and I want everyone to be inside your home, safe at your home, right? Okay, today we are going to learn a chapter 12 in physics, electricity. What is actually electricity? Let's start with an overview of this chapter, electricity. Electricity, what it means. When we talk about electricity, it is most very important thing for our day-to-day life. Without electricity we can't even survive, right? And it become more essential and more convenient form of energy for our day-to-day life. So let's learn what is actually in this chapter, what we are going to learn about electricity, that we will be learning. Electricity, mainly three different topics you're going to learn on electricity: electric circuits, electric charge, and electric current. That means electric circuit is actually the closed and continuous pathway through electric current flows, right? And then I think in 8th standard you may have an experience on drawing these electric circuits. And then electric charge, with two different types of charges we're going to learn, and we already know that when it's positive and negative charges. Then electric current. Electric current is nothing but the rate of flow of electric charge through a conductor, right? So always the charges which is present inside the wire, they started to move from one place to another, right, in an unit time, and that is what actually an electric circuit. So in this chapter mainly we are going to discuss on electric current. So when we are learning about electric current, we're going to learn on Ohm's law. You think that if an electric current is passing through a conductor, it's always directly proportional to its potential differences across its ends. That means if it comes from one end to the another end, you can see there is a charge which is flowing from one end to the another end, and you can see there is a potential differences. What is actually potential difference? It is the work done per unit charge in moving unit positive charge between 2 points. For example, point A to point B, the charge is moving from here to here, right? So there is something work has been done between these 2 points. For example, from here to here, the charge is moving. So when the charge is moving from here to here, some work has been done. That is actually potential difference. So what is actually Ohm's law? We are going to learn through by passing the electric current, right? While passing current pass through a conductor, it's always directly proportional to the potential difference occurs in, right? So and also one more thing we have to learn: while the current is passing in an electric current, definitely you can see some kind of, for example, this wire, think that this is a wire and electric current is electric current is passing from here to here, right? Think that, okay? And you feel, after some time when electricity is passing through this wire, after some time when you go and touch this wire, you feel heat or a warm. Why you feel heat? Because there are something which is present inside the wire, maybe the charges or maybe the electrons. That means they opposes the flow of current, they opposes the flow of current, and that is actually resistance. Okay, so we are going to learn on resistance also. Okay, when we are learning on resistance, there are four different topics we are going to learn on resistance. One is what are the factors that affecting resistance. What happens when the resistance are connected in series. Series means you can see like this, one here, and one here. So series. What happens when the resistance are connected in parallel? Parallel means one here, another here, and another here. That means if the current is passing like this, one here, another here, and another here. So parallel. And then what is actually resistivity? So we are going to find the answers for all these questions in this chapter. Moreover, by using electric power and what is Joule's law of heating. So when we are talking about Joule's law of heating, that means heat is produced in a conductor, right? Whenever there is a current is passed, definitely you can see an heat energy is produced on the conductor. Why it is producing? So why it is producing? Because of these three reasons. Maybe it's directly proportional to the squares of the current. If the current comes more and more, definitely the heat energy is produced. And there is a resistance of the conductor. Yes, of course. If more resistance, more heat energy. And time for which the current passed. How much time the current was running? If the fan is running for the whole day, then go and touch the fan and see. It produces more heat, right? That means how much time for which the current is passed. So we are going to learn on this Joule's law of heating. So this is the overview of this chapter, electricity. Okay, now let's move into this chapter and learn one by one what is actually we are going to learn on this chapter. Okay, let's talk about this introduction of this chapter. And we are not going to complete this whole chapter today. So first we are going to talk on page 199 to 203 only. So only few pages are there, right? And okay, what is the introduction of this chapter? Introduction. When we are talking about electricity, it is controllable and also convenient form of energy, right? That is why we are still using in our home, in our school, even in your wherever you go, you can see electricity is there. So electricity is becoming more convenient, right? Where what are we going to learn from this chapter? So here in this page also we can find the answers for this. Not answers, actually some questions are there. What constitutes electricity? What is it flows in an electric circuit? What are the factors that controls or regulate the current through an electric circuit? So same thing, I have written some two things on here. What constitute electricity and how does it flows in an electric circuit? And we are going to find some more answers for some other questions also in this chapter. First of all, we move on to what is electric current. Electric current. So when we are talking about electric current, or when we are talking about electricity itself, there are two different types of electricity we are looking at it. Now, one is a static electricity, another is current. When we learn, I think in 8th standard, you have a topic that means what are the different types of forces. We learn muscular force, there is contact force and non-contact force. Remember that contact force are the force which something you go in contact with that. For example, if I take this pen, lifting it, that means I am using my muscle. So muscular force I am using it, right? So then that is contact force, right? What is non-contact force? Without touching that, if the force is applied on it, that is non-contact force. For example, gravitation is one of the non-contact force. Static electricity is another non-contact force. Remember that static electricity. What it means? Static means anything which is at rest. Static, it's not moving at all. Okay, how this not movable substance, that means static form of substance, they generate electricity. Take an example, take a scale and a plastic scale, right? And take this plastic scale and rub it on your head, right, on your hair. So while you are rubbing, and it accumulates lots of positive charges where you are rubbing it. And if this scale taken to will be taken to a piece of papers, a bit of papers. Take it closest to the bit of papers, and this scale attract this paper. Am I right? Remember this activity? Yes. So plastic scale will also got some electricity. That means that electricity is static electricity. Why I'm saying that it is static electricity? Because it's not moving from this end to that end. It's not moving. If I rub here and it accumulates charges only here, it's not moving. Okay, that is static electricity. But when we are talking about current means something it's moving. For example, metallic wire. So we are using lots of wires, and a copper wire is the mainly wire we are using. Even alloys, they take the charges from one end and take it to the another end in a second. Just take the charges like that. That means the current which is moving, and this is another form of electricity. So when we are talking about electric current, what is electric current? Okay, let's go to the book and we can look at it. We are familiar with air current and water current. That means why we name them air current, water current? Because air moves, water moves. That means when they flow, right? That means they flow through a conductor. Yeah, that is why we name them as current or electric charge or electric current. That means they move. Electric current is actually amount of charge flowing through a particular area in a unit time or rate of flow of charge. Okay, that is what electric current. How it is expressed? I. What is I? I is represented I is always represented for electric current. So whenever there is an electric current, this is a circuit. You can see there is a cell which is on the circuit. The big line is positive and the small line is negative, and this is a circuit. And this in this the cell, the positive is the big line and the negative is a small line, and always the electric current flows from positive to negative. And you can see that there is a switch is connected. Ammeter is also there, and ammeter is used to find electric current in that circuit. And the bulb is also there. You see that bulb is glowing. Why the bulb is glowing? Because switch is at on position. Whenever there is a switch is on, then the electricity can flow. If it is an open circuit, then the current will not flow. If it is a closed circuit, that means closed means the switch is on, then the current will flow, right? Then this is a closed circuit, right? And look at it. And I is the amount of electricity or the current, right? I is electric current. When a current, what is current actually? The amount of charge. When we are talking about charge is always denoted by Q, and in an unit time T. So what is actually an electric current? Electric current is nothing but amount of charge flowing through a particular area in a unit time. For example, if the current is moving from here to here, particular area A to B, in a unit time, within a second, and that is talks about electric current, right? And current is always expressed by I, charge is expressed by Q, and the time is expressed by T. Okay, and always you have to keep it in your mind, always electric current flows from positive to negative. And also in an electric circuit, the movement of electron will be always reverse. That means from negative to positive only they go. I repeat once again, in electric current, the charge is always flow from the electric current always flow from positive to negative. But in an electric circuit, the direction of the electric current is taken as opposite to the direction of the flow of electron. That means electron will always flows from negative to positive. That you have to keep it in your mind. Flow of electron, and this is flow of current. Understand now? Right. Electric circuit. You should know what is electric circuit. Electric circuit is nothing but it should have a cell or a battery, which should have a switch, a ammeter or not, that's not a thing, main thing, and a bulb. That means this is becoming a closed circuit, then that is what's said to be an electric circuit. Okay, I is equal to Q by T. And what is the SI unit of and each and everything that's we learn. So always current I is electric current is represented by A, and that is a unit of electric current, that is A means ampere. A ampere. And always electric charge is having a unit called coulomb. Electric charge represented by the letter Q and the unit is coulomb, C. Electric current represented by the letter I and the unit is ampere. So what is the SI unit of all? You can say like that. It's very simple. You can write the SI unit using this formula itself. What is the unit of I? It's ampere, right? Q is coulomb, and T is time. Time always we represent it in seconds. So 1 coulomb of electric charge which is passed in a second, and that is called an amp, and in other words it will be an electric current. That means 1 ampere of electric current is nothing but 1 coulomb of charge in 1 second, and this is what the SI unit of electric current. We'll do one simple calculation to understand what is because this question sometimes asked in 1 mark or in 2 mark questions. Okay, calculate the number of electrons constituting 1 coulomb of charge. Calculate number of electrons constituting 1 coulomb of charge. Coulomb of charge, maybe coulomb, you should know that it's Q, right? Q, electric charge, coulomb, right? So and you should calculate the number of electron. There is a formula there. Q is equal to Ne. And what is Q? Q is nothing but electric charge. Unit of coulomb is unit of electric charge is coulomb. And what is N? N represents the number of electron. And here in this question we should find the number of electrons. So we should find N, right? And what is E? E is the charge of an electron. One charge of an electron is equal to 1.6 into 10 to the power of minus 19. It's actually a fixed value, right? One charge of an electron is 1.6 into 10 to the power of minus 19 coulomb. So using this we are going to do a calculation. As we know that we are going to find N, that means number of electron we are going to find. So N is equal to Q, right? Q divided by E, and Q is nothing but electric charge, and electric charge is nothing but 1 coulomb, and electron that we know that, and this is what the number of electron, that is 1.6 into 10 to the power of minus 19. So that is what we have done here. N is equal to 1 by 1.6 into 10 to the power of minus 19, and if I divide it, we are going to get the answer 6.25 into 10 to the power of 18 electrons. So number of electron which is present in constituting 1 coulomb of charge. In 1 coulomb of charge, that means in 1 coulomb of charge, how many number of electron which is present inside? 6.25 into 10 to the power of 18 electrons. So this value also sometime you are going to use for our numerical calculation. So you should keep this value in your mind, right? Okay, next thing we are going to learn here is electric potential. Electric potential. What is electric potential? Take an example. What makes the electric charge flows? How the electric charge flows? If I take an example of water, if it is a water, for example, this is a tube of water. If I am keeping this tube of water in an horizontal place, in an equally level place, do you think that the water flows very fast? No, it won't flow like that. So what we can do, if I want to make the water flow very fast, I can make this area make it little up. For example, if I keep it on the take a tank, okay, and the pipe which is on the tank, if it goes to come to a home in a tube, definitely from the top to bottom the water flows very easily, right? So if it is a water, then definitely gravity works, because gravity brings everything down, right? If I'm keeping the tube like this, it doesn't work. But if I keep the tube like this, because of gravity, that it brings the water from the top level to the ground level very easily. So flow of water will be easily comes. But for flow of charge in a metallic wire, do you think that gravity works? No, gravity doesn't work at all. So how the electron moves in a metallic wire? So the electron moves only if there is a differences in electric pressure, and that is said to be electric potential. Okay, if I want you to explain, if I want to explain more, let's learn the definition. That means work done to move a unit charge from one point means it may be an infinity, wherever it is, to the other point. It looks very simple, right? Okay, let's learn with an example. For example, I'm going to keep one person. For example, we take Rahul. Rahul is a person and he is having an electric charge. Okay, he is having an unit charge. You think that he is having a charge which is like a star. So what is, and where he is somewhere in infinity, somewhere we don't know where it is, and he is having an electric charge. So what he is doing is bringing the charge from infinity to A. A means that we know that there is a point A. So whenever he is bringing the charge, along with that he is doing some work, right? Definitely is doing some work. So what happened, that work done will also be added up with the charge. So he is bringing the charge from infinity to A. Now he is keeping it here, right? And that is what actually we say that as electrical potential. That is, electric potential is always denoted by the letter called V. Electric potential is denoted by the letter V, and the unit of that is volt. V represents volt. And so how can I say that there is some work is done, right? Some work has been done by moving a unit charge from one point to another, right? So W by upon Q. Q is nothing but electric charge, right? Work done, we denote the letter work done, and the unit is joule, right? You know that work is always denoted by the unit joule, and Q is nothing but electric charge, and we know that already, and the unit is also coulomb, right? Let's repeat once again. There is a person Rahul, and he is having some unit charge, and he is bringing that unit charge from the infinity to point A. While he is bringing, that means he is taking that charge and is bringing, that means he is doing some work, right? Work, you know that in 9th standard we learn work. Work is nothing but we are reading the book for the whole night. That is nothing work in that. What is actually work? If I take a pencil or a pen and moving that pencil or a pen to one place to another, I have done the work. You understand? From here to here, that means my work has been done. So same thing is here happening. Rahul is bringing his charge from one place to another place. Along with that, his work done is added along with the charge. That's what here. That means potential difference V is equal to electric potential V is equal to W by Q. That means work done upon a charge, a unit charge. And how to write this SI unit? Electric potential denoted by volt. 1 volt is equal to work done is represented by joule, and Q is represented by coulomb. So how can I say that 1 joule of work is done upon 1 coulomb? That means that is actually said to be an electrical potential. You understand that? And to find this electrical potential, the instrument which is used to find that is called voltmeter. Okay, let's learn what is electric potential difference. And this is also the same thing like that. For example, here I am going to add another name. For example, we add a name called John, and he is Rahul. What Rahul is doing, he is bringing, normally he bought some unit charge from one place to infinity to a point A, right? So he is again bringing a unit charge from infinity to point A. After he is bringing, what John is doing now, he is kicking that, he throwing that charge again to the infinity. That means you throw back the charge again to infinity. You know, bringing from the long distance to point A, Rahul loses all his energy, right? He is using his energy, he's done some work and bringing the charge from one place to another, but the John kicked it, so it went to infinity. You know what Rahul is doing? Again, he's moving from one place to another, infinity, and then again is bringing the charge to another place, but he can't complete A. He can't come to A because he lost lots of his energy. So what he's doing is bringing up to B, not up to A, actually he's bringing up to B. So first time he's bringing really some energy he's having, and he brought that energy up to A, and second time he went back and bringing his charges. Now he can't come up to A, he came up to B, right? So there is a difference between A and B. Do you think that the charge which he bought first time is the same like the charge he bought from the second time? Absolutely not. They are different. For example, the first time if he bought 10, and the second time he could complete, he can finish up only 5 only. That means they are not same. So what is actually potential difference? If I take an example, first time he is bringing VA, that is potential VA first time, is equal to work done A divided by Q. Up to A bought WA by Q, right? The same I'm using here. If I want to write again, I can write first A tak aa gaya. So VA is equal to WA by Q. Second time he can't come up to A, so he came up to B only. And for that it is VB is equal to WB divided by Q. I'm using the same formula and I'm writing it like this. First time, second time. So to find this potential difference between A and B, how can I find? For example, 10, first time it comes 10, second time is 5. What is the difference between them? 10 minus 5. 10 minus 5 is 5. So to find the potential difference between these two, I have to minus A VA minus VB, which is equal to WA by Q is equal to WB by Q. Sorry, it's minus. So this is what actually said to be a potential difference. Potential difference is nothing but you can see the both are not actually same. At first time when Rahul brings the electrons or charge, and the second time he brought the charge. I hope you understand this potential differences. Let's do one example with potential difference. Okay, calculate the work done to move a charge of 10 coulomb across a potential difference of 6 volt. Here they are asking directly that calculate the work done. Work done means you know that it's W, work done. Move a charge always Q, right? And across the potential difference we know that it's V, and just now we use the formula V is equal to W by Q. So what they are asking now, calculate the work done. So they are asking W, right? So keeping this W here and moving that Q on that side become like this, V into Q, right? Denominator go to that side, it become a multiplication, right? It comes like that. You know now what is V? 6 volt. What is Q? They are given here 10 coulomb. Multiply this, and work done ka unit, work done is having the unit called joule. You have to write joule. If you are not writing joule, if you are not writing the units, that means you are missing 1 mark. So you have to write the unit carefully, right students? So I hope today what we learned, I just want to summarize what we learned today. First we learn on the outline of electricity, the complete outline of electricity, what we are going to learn completely in this chapter. And then we went on keep on learning the introduction part of this electricity. What is electric current, definition of an electric current, and the formulas of electric current, and what is electric circuit, right? And how to write the SI unit of an electric current. And then we learned on one example, electric potential, what is actually electric potential, and then electric potential difference with one example. So hope you understand this. If you have any doubt on this, please message me, and then we'll continue this chapter in our next class. Thank you, students.